because I said it's perfect. I can take it. Excuse me, I may cough my way through this presentation. I was going to take it out in the field with me when I go to my daughter's house or anything. Said it would be perfect for that because I can pretty much put it in the backpack the way it comes apart. However, when I went to look to see what the things actually cost, they run anywhere from $300 to $400. So this one here cost $150. That shows you what you can do if you buy your own material and build it. I had to do a little bit of research to figure out what was the best thing. I got to say my presentation has a lot of text in it. I took the text out initially, and I was worried I was going to run into a problem with having to cough through the presentation. So I went ahead and put the text back in so that you could read stuff if I can't explain it to you. But there's basically it was 3 or 4 different manufacturers, and I took the one that seemed to have the best features out of those 3 manufacturers that I looked at. The antenna called the Chameleon was, design-wise, looked like the best one. Now there's all kind of different shapes and sizes you can build these things. If you see from the pictures here, these are different ones that I looked at. Some of them are solid copper, some of them built with coax, some of them use coax for the small, what they call a Faraday loop, which is kind of, and it's hard to keep a perfect circle with that. And the other problem is too that the coax that's soldered to it, like if the example in the lower left-hand corner, coax is directly soldered to the ring. And so if you take this thing apart and try to transport it, eventually the coax is going to break where it connects onto the ring. So I didn't like that system either. So I decided I was going to go with an SO239 of some type on the Faraday loop. Basically, this is what the thing looks like. The numbers and the measurements they give on here are a little bit skewed, but it's basically all it is a piece of coax. This LMR 400 coax that forms a big loop, and the little loop at the top is made out of a piece of aluminum bar that you can buy at Pleasance Hardware or Home Depot or anywhere. All that's in the magic black box is a tuning capacitor, and we'll talk a little bit about that. There was 4 factors that I thought were important to have in here. One thing was that the Faraday loop should be in alignment with the outer loop. The loop should be as close to round as possible, and precautions need to be taken because you actually, when you put about anywhere over 2 or 3 watts into this thing, you have a very high voltage occurring at the tuning capacitor that's in the magic black box. So you need to be sure that you have, number 1, a good capacitor with good plate spacing, and you need to make sure that there's no metal filings or anything conductive left in there after you get finished working. The ferrite chokes on the RG58U feed line are there on the recommendation of the people that designed the Chameleon, saying that they had a problem with RF feedback from it. So I went ahead and put it on there. They recommended on the number of examples that I saw of build your own things on YouTube that you cover the ferrite chokes with heat shrink tubing. Well, you need 1.25 inch heat shrink tubing to cover those ferrite chokes, and that would cost you more than the antenna did. So I didn't put any on mine. If necessary, I'll wrap some tape around it. The antenna should be above ground by at least its own height. It doesn't matter how high it is, as long as it's at least its own height above ground. There is a spreadsheet that tells you how to that you can use to calculate and double check the calculations on it. I've given you measurements for this one, and this one will tune from 40 meters all the way through to 10 meters without a problem. The spreadsheet, if you want to change anything in the design, it works out very well. Tells you, there's a number of factors you can put in to find out if you're barking up the wrong tree or not. The spreadsheet and a copy of the presentation that I'm doing tonight are actually on the club website right now. Bruce has put it up on the club website, so you can go there and download both a PDF file of the presentation and the spreadsheet. Should I build or buy? Of course, like I said before, you're talking about $399 as opposed to $150. So we assume we're going to try to build our own. The construction is simple enough. I have a machine shop, but I really didn't use it to build this. Everything that you see up here was done with an electric drill, a screwdriver, and a few hand tools on my workbench. It wasn't hard to build at all. The basic parts that you're going to need if you build this, you're going to need an 1.125" aluminum flat bar, which costs $4 and some odd cents at a hardware store. The little SO connector, SO239 that you see in the loop up there, those are available from in fact, I give you a list in the presentation of where all the parts come from. You could theoretically use an SO239 and solder a screw on the back of it and do the same thing, but this connector works really well. It's very neat, and it comes with an insulating bushing. So I just went ahead and bought it. I think the connector was $9 or something in that price range. Nothing terrible. The LMR 400 cable is available from a company in California. They sell it by the foot. I bought 6 feet of it. The thing that was kind of hard to find at first was a dual gang variable capacitor that was at least 365 microfarads. I did find one as a company called Antique Radio Supply in Tempe, Arizona. They have a website. They sell parts for restoring antique radios, and one of the items that they sell is a 3-gang capacitors, which you can buy and just use 2 of the gangs on it. That's in the little magic box. A plastic or carbon fiber enclosure. You don't want to put a metal enclosure on it because the capacitor is going to be in there, and you're going to have problems with the box getting RF in it. So use a plastic or a carbon box. The small coax, again, piece of plain old RG58U with the chokes on it. 4 farad chokes, if you need them, are available from the Marlin Jones or any of those companies, probably Mauser and the other company that's competition to Mauser. I'm sure they all have them. The mounting support and hardware, that's where it got to be fun. It needs to mount on a tripod if you want to use it out in the field, take it apart. The problem we ran into, and I'll show you that in a few minutes, is the way we had it mounted on a tripod. And it turned out a very simple solution to the problem. So I'll show you that in just a second. The same thing on the tuning capacitor. The Q on this thing is very, very sharp. I mean, you'll see in the demonstration, I'm going to demonstrate what it sounds like tuning it with a U-Bit-X radio. And you're going to see, I mean, it's right, you all of a sudden fall into the hole and then you're out of it. So you need something that's a variable vernier type tuning dial that will allow your capacitor to be tuned about 5:1 or 6:1 ratio. Those are available, in most of the...
I don't know, someplace on Amazon or somewhere. So I've got power coming out of here, and I've got power going into put some ferrite beads on there because it was being a little noisy. All right, so need to connect something here. Coaxial cable. Now, as we discussed before, the power limitation on here is basically due to whatever the capacitor voltage is going to handle. I've seen a number of videos where guys taken a 6-volt light bulb with a piece of wire, a little bit of loop, and going around the antenna. Up at the top, it glows real nice and bright. All right, that's where the power is coming off. That's where that is. If you look upon this as if it were a dipole, all right, maximum power current is up at the top. I shouldn't say power. Current is up at the top. All right, and it's minimum at the bottom. Conversely, the electrical energy is maximum at the bottom, minimum at the top. Well, maximum at the bottom, that's right where the capacitor is. All right, so you now have a, you know, a limitation on how much the capacitor is going to be able to handle in terms of voltage. This one in here, very similar to the one, it's a 365, plates are close together. This unit will handle about 20 watts, I think, 15, 20 watts, something like that. Okay. This is this antenna. They had just had a sale on it. Sorry you all missed it. It was like $100. But normally it goes for what, about $150 or something like that. You know, Bill was the one that introduced me to this. I think you were the one that said, hey, you saw this. We were at Baker's Fest 2 years ago. Bill had his antenna there and made what, contact with Azores or Canary Islands or something like that? Yeah. 20 what, 20, 15, 20 watts? 10 watts, 10 watts. And he said, hey, and I said, I really like that antenna that you got. He said, I saw this other one that's really kind of cool. You know, so I started looking at that, and you know, it's kind of neat. You know, it covers wide range. I really haven't looked at anything. I'm more interested in 80, you know, and 40 meters, and it does tune down to 80, you know, fairly good. Now, I would have brought my big 20. However, I was making some modifications on it. I like to, you know, I don't like anything coming, you know, that I don't look inside. You know, I've got to see what's inside and see how I can make it better. And, well, my big 20 doesn't work. So I brought this machine here. This is a Zigu G1. It receives from up to 30 megahertz. It has 4 bands output, 5 watts, 80, 40, 20, and 15. And so that's cool. Where it is on here. No, that doesn't look good at all there. Scared me almost. Like, oh, that's the screensaver. So this is the Zigu here. Is that coming up there? Yeah, it is. Let me see, cute little thing. When I first got it, I said, geez, you know, menu, what the hell? How do you operate it? You know, it's got all these little buttons on there. Well, I learned pretty good. I've got this nice little power supply, lithium battery, one that I bought, and you know, there's the power up from it. I wish that the thing I like about this is this screen here is very, very good. It's a little distorted because of the video here, but when you look at it, it's extremely clear. And they have another model, the G90 or something like that. Where is Doug here? Doug, he found yesterday at coffee break, he had a coupon for it. this is $299. Alright, I can afford this in my budget. The upgraded, bigger one is in the $500 range. I couldn't quite convince my board of directors, that this band transmit 5 watts, single side band CW. Nice little, it's not just the size of a QSL card. It's really, this receiver on here is as good or slightly better than on my Yaesu 991A. I was really impressed with it. All right. Now, what's in the back of this here? You can see the capacitor back there. All right. And you see there's the toroid there. You see that toroid? So there's no loop here. Instead, there's a toroid. So what that toroid is doing is it's picking up, basically, it's not a current balun, it's an electric balun, whatever it is. So, the energy is going into that toroid, and there's one loop from here, goes through the toroid, and then there's 5 or 6 loops or something coming out that match it to 50 ohms.
So Ken,
Yes, sir.
So that's in place of the loop that's up there?
Yes, yes. That is, different concept. They're both doing the same thing. They are either taking energy off this loop for receiving, or applying it, for transmitting. So this here one, let's see. I'm connected up and see how much of a signal we can pick up inside here. Okay, now this is my motor control unit here. I'm on 40 meters on 076, all right? And you see the motor is moving. You can see the spectrum analyzer down there changing as the signal drifts in and out. Okay, so that's cool. That's cool. That's nice. Now, that was on 40 meters. I'm going to change it down to, I think I've got it. Sorry. Okay. Never do that when colors and the thing is, I don't wear earrings. I used to, but doing that one time, they zap between,
Plays heck with your hearing aids too, doesn't it?
Yeah, the problem is there was nothing in here to come out that you could listen to. All right, so now we're gonna go down to 80 here. All right, and Now this is a little noisy. I need a bottom on it here, all right? I got some ferrite beads on there, but this makes a little noise. The other problem is this capacitor, you know, is not a feed-through capacitor. You know, it stops at you know, there's like, I don't know, some insulating material, but it stops halfway, and then it rotates and stops the other way. So one of the things that I don't have any end stops on my indicator here, so I got to kind of look at it to see which way it's turning sometimes. Yeah, how fast that went through? But with the knob, I can change, get real slow. I'm not getting a lot of signal coming in here.
Yeah.
Right. So, this is a different way of tuning it. It takes a little practice. You gotta do something. But the thing is, you can put the antenna outside and sit in the house, you know, and do something with it. Now, I bought this, I modified it, you know, it's kind of a no-brainer. So I said, well, you know, I'm smart enough, I ought to be able to build one of these. So, I did, okay? This one here is basically designed for 80 meters, and I'd like to go down to 160, I don't know if I can or not. But you look at this capacitor, you look at the plates between them, and you can see how much more space there is. You know, they're big plates. This has no stop on it also. So it'll turn right around. And this one here, there's my coil. Now look at that baby. That will handle. I'm hoping that this thing will handle 100 watts. This battery is rated at 3,000 volts. Alright. There's my motor in there. There's a hole in the back because I started out with a stepper motor. That's why I found that the stepper motor does not do everything I want. I get better accuracy with just a regular, you know, brush type motor here, or whatever. Flex off from the bottom, you know, sides. You know, they say that it's very important to reduce the resistance in here, and so that's one of the reasons why they solder, you know, the inner and outer connector together in that resistance. I like buying cables from whatever it is. I make sure that they are in fact, you know, soldered, you know, and Teflon one and you know, silver net. This device here is designed to drive a 7-foot diameter loop antenna. All right, that's 21 feet of LRM 400. I just bought 50 feet of LRM 400, and well, I can't go much more than 7 feet, and that is really difficult to work with. You know, when we've set that antenna up, there's almost, you know, 2 guys needed to do it. But I can take that 50 feet of LRM 400 and I can make a double loop. And I think I can come out with probably about a 5-foot diameter. Now, one of the things that that model, that John model followed was they were very precise in terms of size and limitations. That mine is just like, oh, let's take a guess. I think I used 50 feet, maybe 45, maybe 60. Well, 50 feet, it's cheaper to get, whatever. But the thing is, you don't know where the frequency is going to end up. So you just take a good guess. I'm hoping that I can get down to 160. This radio, fantastic reception on 160. I mean, I don't know if the band just happened to be open, but or if the radio was much better than my other one. But I've been listening to CW on there and single sideband, both. The last 3 or 4 nights. So anyway, and this is something too that at our builders group that we talk about these things. And Bruce has been helping me with the antenna analyzer. I've got antenna analyzer, the same one that he bought, and I found out that either I don't know how to work it or it don't work. I was going to have show JPEGs or whatever of stuff that we can see here, but I can't get them. I either get flat line, zero standing wave ratio, or infinite. And anyway, topic for another day. So what I can do is, this is the device, the D4D, and you can see here we got a number of selections. I think you have $20 shipping though. So what we've been able to do is negotiate, with the builder that we can get a break on the shipping and a little bit off. So the unit to us ends up being $39, including shipping and everything else. So hopefully we'll make that available to anyone. And like I say, if you need some assistance building, we've got that. But the circuitry itself is pretty self-explanatory. I found I didn't know MFJ sold all these parts in their catalog. I was kind of surprised by it. But there's a number of capacitors that could be used. This one seemed like a good choice that I may purchase, and it's reasonable, $40 or whatever. They got some really big honking ones. But the problem is, you need, a small suitcase in order to build it. So because I've got some of these extra, I'd like to try and fit it in there. And so there's a number of selections anyway that MFJ has. And in terms of propagation, again, it's all off in that direction. It is fairly directional. All right, so that if you've got, talk to somebody over there, turn the antenna toward it, be able to, block out some things also. This antenna is a compromise antenna. The best antenna is if you have at least 120 feet of space and you can put up a dipole, or if you have a homeowners association that doesn't understand what a 100-foot tower is with a Yagi on top. When to solve that problem. But, those are antennas that you would like to have, but not everyone has that ability. This is becoming more and more popular because a lot of us, senior people, as I like to put it, live in an apartment. We sold the house, the wife is gone, the kids, don't talk to you anymore, you're by yourself, you got your time on your own, but you're in an apartment which does not, give you a lot of opportunities to transmit. First or second floor apartment, even with just the window, nothing else, you have this, you wouldn't even need a motor to you can tune in by hand, you know, and the radiation won't kill you. You know, you probably don't have 50 years left to live anyhow. What's a little radiation, you know? Anyway, any questions? Yes, sir.
I got a couple questions.
Sure.
On your homemade box, are you connecting or it looks like it's got some air reduction, correct?
Oh, I'm sorry. This motor is a 4 RPM. Yes.
And did they come from a grill or where you buy it?
Amazon. I get everything from Amazon because they get free shipping. And the thing is, if I bought something really stupid I don't like, I can send it back. You know, so they do good by me. I see the Amazon van every day. I know them by name. His family, the kids, you know, everything else. But the motor was $10–12. I had some of these around. They're 31, so they cover up to 30 megahertz. You know, from 500 kilohertz or whatever to 30 megahertz. And they're big honkers. They'll handle, I think, 300 or 400 watts.
And I noticed there's a difference in the structure between that that has the coil on the top and your toroid is at the bottom. So I mean that was kind of opposing the opposite of the capacitor, and this one is on the same end as the capacitor. Dynamic on that is?
No, that one capacitor is still at the bottom.
The capacitor at the bottom, but the small one's at the top.
But that's only the pickup loop. And my pickup loop is in here. Let me go back. See, there's my pickup loop. In that toroid. You know, like just like this one here. So, but the thing is, it's transferring the electrical component of the wave. That one is transferring the magnetic component of the wave. That's the difference between them. Not something I totally understand, but it's, you know, from what other people have done and seen, it works. You know, so yeah, I'm the kind of person I'm willing to steal any idea, good idea somebody else had, to use it for myself. You know, it's just kind of, there's a lot of ideas out there that, you know, are really stupid. You know, but they work for me. Any other questions? Thank you all. Appreciate it.
Thank you, John.
Builders Group meeting on Tuesday. Builders Group meeting on Tuesday.